Okay, welcome to the meeting for today, this week. We had to cancel last week because of scheduling, but I think we should be all right. For Ujjwal is going to present his paper choice, and then, Vinay also wants to present something, or he wants to share a screen for 5 minutes at the beginning of the meeting here. So I should ask first, does anyone have any questions or comments about what's been going on this week? I know I've talked to some of you on Slack.
Nothing yet. Maybe we can proceed to the boards.
Okay. Did you want to present your thing at the beginning of the meeting, or?
Yes.
Yeah, once we
Today I have to present a paper, right?
Yeah, we'll do that in a little bit. I just wanted to get some business. Yeah, maybe we'll do that like after the boards. But yeah, your paper presentation. So we'll just why don't Vinay should show his demo or whatever, and then we'll do the boards, and then we'll do Ujjwal's presentation. Does that sound good?
Yes, sir.
Okay. So Vinay,
I have about a couple of images to show, and the progress. I want to show some code that I've written.
Okay.
By going through the boards, maybe we can. I'll be sharing my screen so that we'll address each of the board and we'll see how much progress has been.
Okay. So you want me to share the link to your board, or?
Yeah, if others want to follow, they can, right? Yeah, you can.
Yeah, I'll just share the link to your board. So Vinay's board is in this location. So it's in this repository. And if you go to this repository, you'll go to the Projects tab. And then there's the DevoWorm Summer of Code project. You click on that. And then the board comes up. Okay. So, all right, how do you want to do this? Do you want to go through the board and then present, or?
Yeah, I want to go through the board once and then show some images that I've got after training the model.
Okay.
So, yeah.
Okay, so we'll go through the board. So we have a bunch of things that are done. The Python scripts for plugin is done. Setting up environment is done. Preparing slides is done. Digital notebook is done. Solid objective for feature analysis is done. And then we have a couple of things in progress. So the one, number 8, is set up, use deep learning for J, which is something I think you proposed this last week. And I put the tag on that it's a linked issue, but I can't remember what it's linked to. But I think there are going to be other things that we're going to put on the board that are linked to it. Is that correct?
Yes, exactly. I want to show. I'm having some error with. I'm limited with some deep learning for J functionality, so I want to discuss about that also now.
Okay.
Coming to the second board, implement the unsupervised approach. That needs to be done by in the phase 1, right? So that should be in progress.
Yeah, like we were talking about that, I guess, this last week. So your plan was to like run through what you have. You want to use. You don't want to have to go too deep into like any special types of techniques, but you want to finish that up like this next week or two, and then move on to phase 2. So that was my understanding of it. So you're going to implement an unsupervised approach, and then implement a supervised approach in phase 2.
Yeah, exactly.
Okay, yeah. So that's issue 10. So those are both in progress. Select a paper to review. You finished that. We have that on the schedule. Let's add in another. You're going to work on your paper presentation.
Yeah.
And I assume that's just in progress, so we'll put that in progress.
Yeah, I read the paper. I've gone through the paper twice. Now I'll have to make some notes and put that onto some present slides.
Yeah. And then you'll see, you'll see how Ujjwal does it this week, and then, you'll have some idea of what we might want to talk about, because we'll talk about the paper a little bit as we go along. As we get, at the end of the presentation, there will be a lot of questions. So, okay, so then number 16, conclusion of plugin development, scheduling additional time for enhancement. So this was where you're coming into the end of phase 1, but you want to be able to come back, maybe if you have time at the end of the summer, to make enhancements to phase 1.
Yeah, the thing that I want to present is regarding the board number 16 and the board number 13 introduced.
Okay, so let's see. Board number 13 is build a plugin Java.
Yes,
Okay.
yes. Now I'm able to generate the output images from Python, so that now I have the saved model from Keras. Now I'll have to import that into deep learning for J, right? So for that purpose, can I present right now?
Yeah, go ahead. Go ahead.
Yeah. Please give me a second once.
Okay. Okay.
Yeah, you can see my presentation.
See the screen, yes.
Yeah, thank you. First of all, I want to share some images, the output images. This is one image that I've got after training the model with some hyperparameter tunings. And to that, I've made some changes to make it more, to make this more clear. Oh, so yeah, here it is. Here you can see, actually this is the original image. This is the test image that I've sent through the model, and this is the output image that I've got. Of course, it's resized now. I'll have to resize it back. Here you can see all the noise getting cut off and the boundaries being highlighted. So that's the current state of progress for this unsupervised approach.
Okay.
And regarding the enhancement task, what I wanted to do is that here you can see that the line is not getting traced here.
Yeah.
That's because in the original image itself, it's barely visible. So the enhancement part that I want to do is that to see if I can even trace that fainted boundaries also. So that's so that is the task that I want to schedule some time towards the end of the entire JSOC project.
Okay. Yeah.
That is regarding board number 16, and coming to board number 13. This is the code that which produced the output that I just showed. Here, towards the ending of the encoder, here you can see this is where the encoder output is. This is where the image is coming from. On the last layer, I needed to use some a custom layer instead of some pre-built layers from the Keras. So I've implemented a custom layer, and this is how you load. This is the trained model. From this trained model, I've gotten the output images, and as this model has some custom layers, so I will have to pass that custom objects also whenever I'm loading the model. So for deep learning for J, I cannot do this. This custom object cannot be passed. It seems like I've done some research and currently support they have no support for this type of functionality.
Oh,
So that kind of a limitation for me. And but obviously there's a workaround for that.
yeah.
For that purpose, I've used some lambda layer. In this lambda layer, I will don't if I use this lambda layer, I won't have to pass this custom object. So that's a workaround. Uh, I'll have to focus the coming 2 days on this thing, eliminating for the need to pass these objects like this
Oh, okay.
using lambda layers. Yeah. So
The,
hopefully yeah.
so to be clear, the problem is a coding convention, not that you don't have the function in place. Like that you basically J doesn't have custom objects, or how does that work?
Yeah, actually, in deep learning for J, it's basically there's a function like this in the Java code where you have to pass the model like this, but
Yeah.
they don't have a parameter support. They don't have a place for parameters like this.
Okay. Yeah.
So yeah, my current state is that without passing this custom layer to while loading the model, I cannot get the output. So that's the current limitation. But then they have a Gitter channel for the support for technical support, and I've asked them. They told me to use some lambda layers, which will eliminate the need to use this thing. So I'm currently at that point. I'll have to try out how that goes in the coming by Sunday. Maybe I'll be able to do that.
Okay. That sounds good.
Yeah. So that's all I have to present. I wanted to show that output. Yeah.
Well, okay. Thank you. Yeah, that was helpful.
Yeah.
And
Can
so
I talk?
that is issue 16 and issue 13. And let me
Yes.
actually put in let me see if I can put some labels in here for these two to make sure that they're linked. We have, oh, it's not coming up. Oh, I probably don't have it on this one. Oh, I must have it on this one. I'll do it later. Okay, so yeah, 16 and 13 are linked. And I'll make
Yes.
that note later. And then now we can go to the other to-do issues here. So the first one is number 17, begin work on semi-supervised approach. And you're telling me that that's going to be like within the next week or two that you're going to start on that approach.
Yeah, yeah. Once I'm done with this unsupervised approach, then I'll soon begin to work on that.
Okay. And then the next one, number 15, was something that came out of our discussion last weekend about outreach. And so this might be something of interest to Ujjwal and Azmit. So I went to a conference this last week. That's why we had to cancel the meeting last week. And I presented a poster on, what's kind of going on in DevoWorm with an emphasis towards kind of some of the educational outreach things that are going on. And so I have the poster. I can share a link in the Slack channel. But basically, it's an open poster. So anyone who wants to, use it for any other purpose, like if they want to print it out or if they want to make, changes to it, don't make changes to the original. But we can talk about if you want to make changes to make it a little bit, more suitable for your needs. But the idea would be to, do outreach at your home university. So if the people who worked on this worked on Summer of Code back in 2017 and 2018, they both have been doing that sort of thing. They've been doing outreach at their universities, and they've been trying to get interest in the project and in Summer of Code. I know Google Summer of Code actually offers outreach materials, but I think, educational for the students in those, at your university. So, that's something, though, that Vinay asked me about specifically, so I provided him with some material. But if you guys are interested, you're welcome to. We can have a talk about that. No, issue number 12: implement soft cut normalization loss. So this is something I can't remember exactly where we left that. Is that something that you're going to do, like, when you revisit this phase 1, or is this something that is upcoming? As I know we talked about loss functions a little bit. Hello? Did we lose Vinay, or is he still there? I don't know.
Sorry, I got my mic off and I was talking to myself again.
Oh, okay. Sorry. Yeah. So we have a question from Richard Gordon. He's with us today. Well, actually, let me ask you, what is the image being enhanced? We know when you were sharing your screen.
Yeah, the model that I've built takes an input image of a spin image of a embryo of C. elegans. So I want to enhance like I've showed you the output, right? Like what my model produced. So in that output, some edges are some edges are not being traced. So the enhancement that I want to do is that try and get that faint edges detected. That is what I have to say for that.
Okay. Oh, well, yeah, to answer his question as well, these are spam images that we got from some publicly available spam images that existed in movies, and the movies were decomposed into images, and then the images are being, those are like test images to see how they can be segmented. It's spin microscopy. I can't remember the name of the type of microscopy. Let me see if I can find it in here. I can't remember the name of what the acronym stands for, but I'll show you later, like where it comes from. So, yeah, selective plane elimination microscopy. I think that's right. I think that's the right one.
Okay.
Yeah. Thank you, Esmet. That was. Okay, I have too many tabs open here. So let's see. I was actually, when you were talking into the mic, into the ether, I was asking you about issue 12, implement soft cut normalization loss. So is this the thing that you're going to do, like, if you revisit the phase 1, or is this something that you're going to do in the next 2 weeks or so?
Yeah, for the next 1 week or so, I don't think I'll be revisiting this, because when I implemented that from the paper, from the mathematics that I understood, I not see much of a huge difference or some advantage that it gives for our output. So I thought of discarding that and going forward with the normal loss function only. So for the next 1 week or so, I'll be working with the ordinary loss function itself. And when I come back to this again, uh, maybe I'll have a look at it. Maybe if I've got something wrong or something like that. As of now, I don't have any plan to revisit that.
Okay. I'm just making a note in the issue.
Yeah, sure.
So we'll just leave this in the to do, and then I have a note in it. So that's number 12, and then last one, number 11, segmenting Brakefield images. So that is I think that was because you were asking me about data that you were saying that you needed more data, and I was giving you options as to what kinds of data we had in the repository that I showed you, and I don't. Then you said you were going to do some data augmentation, so kind of maybe that fell through the cracks a bit.
Yeah.
Yeah.
Actually, the data augmentation that I wanted to for the is for this unsupervised approach itself.
Okay.
So, but that segmenting bright field images is what I wanted to do for the phase 3 of this GSOC.
Okay. Yeah, I see.
The thing I told you about data augmentation, uh, like we only have a limited data, right? So I've added some randomness into the data, tilted some images. I've also uploaded the code into the repo, main repo. You can check it later.
All right.
So based on those generated images, I've trained the model so that it will be resistant to light changes or rotational changes or any of such distortions. So yeah, that is regarding that.
All right.
And segmenting bright field images is I wanted to do that for the phase 3 of this project. Yeah.
Yeah, I have a note on it. So I'll make a new issue. Data augmentation strategies, just a very general thing, and I'll assign it to you, and then put it in progress, and then that'll just kind of cover a lot of the things that are going on. So when we come up with something a little bit more, specific, we can like add issues to it. So as we usually do. So now, given that, do we have any issues we need to put on the board for next time or for the next week or two?
Yeah, like now I discussed the limitation of deep learning for J for that custom objects. That's the only I see for the next coming week.
All right, I'll put that up as an issue. All right, I think.
And all other things seem fine to me right now.
Okay, yeah. So yeah, if you can think of anything over the course of the week, you can put them on the board yourself, or bring them to the next meeting. We kind of debugged a little bit of stuff, during the week, and we didn't put it on the board, but that's okay. This is just a general kind of take on this. So now we're going to move to Ujjwal and Asmit. Thank you, Vinay. And we're going to go to the Digital Basel area board. So let me put that in the chat. There's our repository. And then we go to the Projects tab. We go to the Digital Basel area link there. And here's the board. And so let's go through the board from right to left to do, and we'll kind of get some updates on where these issues are. So in the done category, we have a bunch of things here. Split Basel area videos into frames. Work on a README file that's kind of in progress, although that's kind of done for now. We might work on it a little bit later. Manual mask creation. Define training set, create data set, create digital notebook, choose a segmentation procedure, model selection. So yes, we've gone through all of these, and I got an update last week on what was going on, which was basically you guys were, throwing data at the model and training it. And so let's see, we have a bunch of things that are in progress. But I actually want to hear an update from Asmit and Ujjwal. You can. Okay. I'll share my screen here. Let's see. I'm not getting that. here we go. So, are you guys there?
Yeah.
Okay. What's the update on what's going on?
So, like the main working on is the Kaggle model we are trying to train. So, like throughout this week and last week, we've been tackling like some issues regarding that only, and we hope that by next week we can like properly uh, train it train it to get our output. And after that, we have also worked on this week regarding the like after when we get our segmentation. So how we are we gonna like take out the features. So we read on some maths about like finding the velocity and the other features that we need to extract. So on this weekend, like on the next week, we'll be still working on the Kaggle model, and we'll be trying to like get a final output and get it working.
Okay, so you're kind of still working on it. Are there any
Yeah,
bottlenecks in that part, or is it
like
just going along?
not exactly bottlenecks, but yeah, like we were getting stuck on some things regarding the environment and our local systems. So after figuring that out, I guess through the next week we can do that.
Okay, so what are you using as a program for the? We talked about like Kaggle kernels, and then what did you decide to use for it? Oh, I
Hello.
got dropped off. Yeah.
Yeah, so we have decided to train our models on Kaggle. Actually, Kaggle is new for us, so we have tried to figure it out, like how it's working, all these things. And Kaggle is really doing a great work. So we have almost on the finishing part of our training, and I think that most probably we will able to train our models by Monday. And after that, we have side by side started working on mathematics, like how we can calculate the features between the frames. So, like as Dashmit has said, like we have taken some XML codes and tried to figure out like what are the location of bacteria in different frames. And we are trying to find displacement and trying to find like we can do some mathematics. So we are reading about it and we are trying to frame a model of mathematics for that.
Okay. Yeah. But why don't we, when we get to that stage, why don't we start working like having a dialogue on that? Because I'd like to see kind of like work through it with you and see kind of what your ideas are about it. Because we've been talking about that sort of independently. Richard has been working with. We've been talking with someone else, but you know, it'd be nice to have like everyone on the same page about it and kind of have like some more open discussion about the direction of that. So just, I mean, we can actually, we don't have to all be in the same meeting, but we can kind of share notes and so that we can like read each other's notes and think about what the best answer is for that. I mean, it's a matter of just kind of proposing something, maybe working it out a little bit, and just kind of in practice, and then once we like think, oh, that's a good idea, maybe you should scale that up, and we can do it. So I just wanted to make you aware of that, so that we don't you don't disappear for 2 weeks and then come up with something and then it doesn't work well. Oh, hi, Asmit. He's back.
Yes, sure. So, like, we will share our, whatever we are doing, we will share our notes with you as well.
Yeah, I think that's good.
We are at the beginning phase of like forming the mathematical models, and once we have some concrete results, we will surely share it with you.
Yeah, that's good. And I think there's because we want to be able to go back and forth on it and see which things are maybe most workable. Maybe if you come up with some mathematics that don't scale up, that's going to be a problem. So it's always okay. So Richard sent a note here. Our meeting. Okay, let me go back to the chat. Our meeting with Thomas Harvich, Germany, is at 20 UTC today. Will you guys be awake? So 20 UTC is what in India time?
So it's maybe like 9:30 plus 6. It's maybe like 3:30 a.m.
Oh yeah. Well, that's yeah. 1:30 a.m. Well, you don't have to make it if you can't, but we'll I can relay the information to you. I can again, but we have to keep kind of kind of think kind of together on this. Anyways, so let's go back to the board real quick because we're 30 minutes left in the meeting. So in progress, we have work on technical details of the data set. We have adding information about the biology of Basilaria. We're still working on that. Model evaluation, schedule and present papers. That'll be something we'll be doing today. Mathematical model development. We just talked about that. And then the Kaggle kernels. Is that something that you want to put in done, or are you still kind of working out the details of that?
So actually we are working on Kaggle kernels and we will be completed by Monday. So we will put that in done on Monday, I guess.
Okay. All right. And then so to do, we have convert records.
Yes, so this part is done now. We have converted to TF records.
Okay. Create video resources for Basilaria biology. That's still to do. Define features within and between frames. That's going to be part of that, I think, the mathematical modeling thing. So we'll leave that in to do for now. Are there any things that maybe we can put on the board for the next week or two that you want to put on the board as issues?
I guess the defined features within and between frames is the main thing after that. So it's again an umbrella title for all the the main things we're going to do after that. So I guess that's that for the next couple of weeks. Define features and between frames and try to model them.
Okay. Or well, actually, I know how to do this. A model. So I'll create a new issue, model features within and between frames, maybe. And then keep that as a separate, defining the features, because it'll be sort of a different step. And then we'll put in, I'll assign that. I'm going to put in, maybe it's linked labels. Well, we can put the labels later. Okay, so that's about it for the number 3, number 28 would be sort of the next couple weeks. So, okay, that sounds good. I mean, we'll maybe make some issues as we go along, but I think that's good. Okay, now finally we get to Ujjwal, and he's presenting a paper today. And you'll have to share your screen to do this. You have a separate connection for screen sharing. All right, there we go. And there we go. ImageNet Classification, Deep Convolutional Neural Networks. Somewhat of a famous paper, I guess, in the field. So
today I'm going to discuss about ImageNet classification with deep convolutional neural networks. So this is the one of the benchmark paper which is written by authors Alex, Ellie, and Geoffrey. These all are researchers at University of Toronto. And so before starting, a brief description about the authors. So Alex is a researcher at University of Toronto and now he's working with Google. At the time of when he published the paper, ImageNet paper, he was a student and he and his mate Ilya worked under Professor Geoffrey on the ImageNet competition, and they have done really well, and they have set a benchmark for around 2 to 3 years until the Microsoft has break it in 2015. So a brief description about Elix is that. Now brief description about Elia. So its Scaver is a computer scientist working in machine learning and currently serving as a chief scientist at OpenAI. He is also a student of University of Toronto. He has made several contributions to the field of deep learning. He is co-inventor of famous LXNet. LXNet is the another name of ImageNet paper. It is named on the researcher Alex, who was the major contributor in this paper. So he invented sequence-to-sequence learning, and together with Vinyals and Quark, and he's a co-inventor of AlphaGo and TensorFlow. A brief description about Geoffrey. Geoffrey Everest Hinton is an English-Canadian cognitive psychologist and computer scientist. He is mostly famous for his work on artificial neural networks, and since 2013 he is working with Google Brain and also teaching at University of Toronto. Now coming back to the paper, a brief description about paper, like brief overview. So AlexNet is a name of convolutional neural networks designed by Alex and published with Elia and Geoffrey. Was originally AlexNet competed in ImageNet large-scale visual recognition challenge on September 30, 2012. The network achieved a top 5 error of 15.3%, more than 10.8% points lower than the runner-up, which is a great margin. The original paper primary result was that a depth of a model was essential for its high performance, which was computationally expensive but made feasible due to utilizing processing units during training. So main part of this whole research is like they have their images on multiple GPUs simultaneously. So basic methodology, paper abstract. So it is abstract. It is a screenshot of an abstract of paper which they have written. I hope I have shared this paper already, so you might have read this. So this is a seminal paper that introduced AlexNet, a deep convolutional neural network that won the ImageNet contest. That contest has 12.2 million images, each belonging to one of the 1,000 classes. This paper launched the current craze over CNN on the query of Google Scholar returns. Like in CNN, the Google Scholar has 1,400 papers from 2000 to 2011, but after this paper, the paper 1 year has 5,500 papers. So it is a very big increase. So they are the one who bring the attention towards convolutional neural networks. So when it was published, this paper managed to train one of the largest CNN to the date, which they did through a number of key improvements, including a very efficient GPU implementation and architecture that allows training to happen on multiple GPUs. The demonstration that the now ReLU non-linearity significantly decreases the training time. They have given some concepts of ReLU non-linearity, which is very useful to reduce the time. Then they are in the danger of overfitting because they are using multiple GPUs. So they have also developed an algorithm known as dropout, which is very famous algorithm and which has been introduced. So as I have discussed about the paper, like these are the 4 major points of interest in this paper, like what is ReLU non-linearity, training on multiple GPUs, overlapping pooling, and data augmentation, which covers dropout algorithm. So ReLU non-linearity. Notes, yeah. So each neuron in the neural network computes weighted sum of its inputs, applies an offset and then runs result through a non-linear function. Historically, like most popular non-linear functions were sigmoid. This paper made a strong demonstration that the ReLU nonlinearity significantly reduces training time on deep networks. They have emphasized on this ReLU nonlinearity function, and the reason is likely that for positive activations, ReLU derivative does not go towards zero. This is an important benefit since the derivative close to zero means the gradient descent will converge very slowly. Naturally, with negative activation of ReLU derivative is zero, which means like when there is negative side, it won't learn anything. But as long as it has some neurons that have positive activation, then the part of network will be learning. It appears that it's better to have only a subset of neurons learning very efficiently than having most of the neurons learning very slowly. So this is the thing that they have emphasized and they have figured out. So now, if as you can see in the figure of ReLU nonlinearity, this figure shows how much faster a network of ReLU nonlinearity learns as compared to different nonlinear functions. The magnitude of this effect naturally depends on the network and task, but since this paper has been published, the advantage of ReLU has been confirmed in many other applications like in natural language processing and other deep learning methodologies. The ReLU nonlinearity function is widely used nowadays. So this is the thing about ReLU nonlinearity functions. If you think like you are not able to understand like some terms, so I would suggest like you can go and read chapter 6 of Michael Leenson's Neural Networks and Deep Learning. They have explained it every term very good in a very good manner, and so you can refer it as well. Now coming to training on multiple GPUs, local response normalization is the term that is given by them in their paper, and they have like calculated a very deep formula, we can say, like it is a very important formula of training multiple GPUs, which was not so common at that time. So they proposed a network is too large to fit in one GPU. So the author proposed to use the fact that modern architectures allow two GPUs to write from one another's memory. Their final architecture is a column network, a term I have heard used a number of times since that paper. In a column network, each GPU operates more or less independently, except on some layers where they cross over. Using two GPUs reduces the error rate by 1.2 to 1.7% as compared to a single GPU network, because there are two GPUs which are working simultaneously. So error rate will obviously reduce. The single GPU network has roughly half as many as convolutional kernels as two GPU implementation. So kernel is like if you imagine a data set in the form of matrix. So kernel is like a small matrix filter over that image. You can imagine it like that. As in my slide, you can see kernels being demonstrated of different kinds. Coming back to paper, like the goal of that is slightly scale equation to encourage different convolutional kernels to learn different features. The kernel is a matrix applied on a square area of pixel, as I have just shown you example, like there are different kernels. Each entry in the matrix multiplies under it, then the neuron sum ups everything, applies the offset and passes it through non-linearity. The problem occurs when two kernels have very similar matrices, which causes them to detect similar features, which in turn reduces the expensiveness of network. This is what the equation here sets out to solve, like the equation I have shown you. The equation first imposes an order to kernel and looks at n adjacent kernels. The chosen order is totally arbitrary. If two kernels are adjacent, it doesn't mean that they are close together on the screen. It just means that the random order picked them to be neighbors. For each kernel, the equation inhibits an entry in a matrix if the adjacent kernels have high value in the same entry. Like the entry of the kernel 3 will be inhibited too much because of the star entries of the adjacent kernels have very low value. As you can see, like the stars are very dim in the kernel 1, 2, 4, and 5, whereas the cross marks in kernel 1, 2, 4, and 5 are much darker than that of dots. So, where entry B will be more strongly inhibited because star entries have very high values. Using these techniques, they again reduce the error rate by 1.4%. So they have beaten their runner-up by 10.8% of error rate, and they have already improved by, I guess, 2 to 4%. And they will be improving as we discuss more and more techniques. Overlapping pooling. So this is the image that they have presented in the research paper, illustration of the architecture of their CNN, explicitly showing the delineation of responsibilities between two GPUs. One GPU runs layer part at the top of the figure, while the other runs the layer part at the bottom, as you can see. So another improvement is like they use overlapping pooling. A pooling layer is typically applied after a convolution layer. Its role is to downsize the image by gathering together a small window of pixels. In the prior work, the given pixel was only used in one for pooling neuron. In this paper, they have proposed to overlap the pooling windows so that the same pixel can be used by two different pooling neurons. This is the thing which they have applied in this paper to reduce the error rate further by 3%, which is a very large margin. To understand it, like some with definite figures, we can see like if we assume like the inputs of 224 cross 224 image with 3 color channel, that is RGB. The first layer 96 kernels, 48 per GPU, are applied to this image. Each kernel has size of 11 cross 11 cross 3, and they are scanned over the image with stride of 4 pixels on the X and Y directions. The result in 96 images of the size 55 cross 55, 48 such images per GPU, which are run through the max pooling stage. A figure is a bit misleading regarding the max pooling stage. As you can see in the figure, it looks like the max pooling stage comes at 5 cross 5 convolutional kernels, which is like slightly incorrect, as we can see clearly like max pooling stage comes before 5 cross 5 in the transition between 3 cross 3 to 5 cross 5. So it is like just maybe an illusion, or it is just maybe incorrect. So coming back, so next 256 convolutional kernels of the size 5 cross 5 cross 48 are applied on each of these 27 cross 27 images. Like if you are noting what I am saying, like if you are drawing the images, you can see like we have made a small kernels of 27 cross 27 images. That stage clearly shows that the impact of having two separate columns of each kernel is applied on only 48 out of 96 available images. And this thing goes on as we move forward, and they have total of 37.7 million images, which they have divided into two GPUs in 16.8 million images approximately. So this is the way how they have countered the fact like they are using two GPUs simultaneously to train a single model, and they are able to train such a large model for the first time in that era. So this is something about overlapping pooling. So data augmentation, a good way. This is the dropout algorithm which we are talking about in some times ago, and this is a screenshot from their paper. You can read it. So the summary of this is like it is a good way to make a most out of dataset, often to augment it by distorting each sample in a way that ensures the label stays valid. The author do this here by applying transition and horizontal reflection, increasing the number of training images by a factor of 2048 in process. This data augmentation step is critical to limit overfitting. Another distortion they apply is the change of RGB color value of all the pixels every time the image is encountered in training. The proposed distortion captures the fact that natural images are invariant to changes in the information. If you are lost about how the PCA and RGB space works, you can, as I have attached some reading materials at the last hour slide, you can refer that. So this is a dropout algorithm is very clear as it is written in very easy words in the paper as well. So you can read it, and it's interesting to know like even with the every mechanism described below, the network has tendency to overfit, which the dropout has fixed, because if you are using training data on multiple GPUs and you are using all kind of the techniques which are illustrated above, there is a very big risk of making data overfitted. So dropout is the technique which they have proposed to ensure that these things doesn't happen. So these are the links for further reading which you can refer. And if you have any questions like regarding this, you can either text me on Slack. And these are the major points which I think are takeaway from this paper. And if we talk in the context of like how it is useful to us, so I think as far as I know, Vinay's project use processors like Deep Convolutional Networks are always very good there, and we can also use this technique, but the problem which we are facing is like we don't have to only segment the images, we have to make models and we have to do other stuff like finding features between frames. So we found out like this is not the benchmark anymore, and DeepLab v3, which is proposed by Google in 2018, is now a benchmark technique. So we will try to get more and more about our models and more good models, so that we can get more and more accurate details. So that's the one reason why we haven't opted it. And if you are going to like, if you want to reproduce this code and want to, it's a very huge data set. It may require maybe a very powerful GPU. So, but you can go through the paper, and I think the code has been open source. You can find it on. Easily go and try your hand on it. So thank you everyone.
Well, thank you, Ujjwal. That was very good. I have a couple. It looks like we have a couple of questions here from people. There was a robust chat going on in the during the talk here. So it basically we have.
So I will try to answer each one. Like how many layers to qualify a deep network? So deep network, like it ranges from like the current model which Microsoft has proposed in 2015 has more than 100 layers, and like if it depends on your task, like what you want to do. Like if you are easy, like you want to do some research and state of the art product, so you have to go more and more deep. Like Microsoft has gone for 100 layers. But if you are doing some task for like some research purpose, but it is not so significant, so you can go for 10 and something like that. So it ranges from 10 to 100 for now.
Is there any? Has anyone ever done like a study of, what it means to add layers? Like, if you have 2 layers or 100 layers, it's obviously more powerful than 2 layers. But why, is there any sort of understanding of why that is? Or like what each additional layer adds? It would be like, if you added like in a more maybe deterministic system, it would be like if you added power to something, it would increase and then you could get like a curve or performance curve.
So I think like if you add more layers, you are extracting more and more features. It is like you are like in one layer you have extracted some feature, then you proceed to next layers. You are extracting more and more feature and making it more and more defined. So this is a parameter like how defined and how accurate you want your data set to be. It may be a trade-off, like if you are using 10 to 12 layers, so it takes less time, but it may be not so accurate. But if you want to make a state-of-the-art product and you are using lots of GPU power and lots of layers, so like it may take a lot of time, lot of money, but it will give you a very better result. So there's always trade-off in between them.
Yeah, I have something to add to what Ujjwal said. Uh, when you're increasing layers, it usually means that you are also increasing the number of kernels for each layer. Now, what a kernel does is that it will extract a specific feature from the maps that it got from the previous layer. For suppose if I put some number of kernels is equal to 3 in the first layer, maybe it will extract all the horizontal lines in the image, all the vertical lines in the image, or maybe some diagonal lines in the image. So when you add on layers and keep increasing the kernel size, the model will learn to look at features which are not visible to our eyes, like some more deep features may it will learn to extract. So that is the use of adding more layers.
Okay. Well, that's good. Thank you for that explanation. And so I think the conversation here was sort of in the same vein. It's just kind of like, why would you add layers? You're just adding, kind of gave the explanation, I think. More than 3 layers counts as deep. So, yeah, I guess it's, you have to get into the feature space, I guess, to really understand what the trade-offs are. So I think that was a good talk. For future talks, I would recommend that you lean on being highly visual. Like, maybe, add in as many figures as you can, or even if you have to find a figure online to kind of illustrate your point, that's always good, because it's better to, especially with this type of topic, or these type of topics, if you can visualize it, it's a little bit easier to understand than to, wade through some of the jargon that they use in the papers, because they do use a lot of specialized language. And, you can understand it, but it's easier to understand the broader concepts if you have images. So, I think Ujjwal did a very good job, and I think that you guys, Vinay, and I think Vinay is next week, or is it Asmit? I can't remember right now.
Mine is next week, I guess.
Okay, so you guys, we have the schedule on Slack, so you guys are prepared for this, and so hopefully if you have any questions about that or about the projects in the next week, let me know. On Slack or email, or even if you want to set up some FaceTime on Google Meet, that would be okay too, if you have a particularly urgent problem. But also, Vinay, we have the first evaluations coming up. So those are coming up in the next few weeks. And again, it's something I have to do as well as you. It's not that hard. I think you'll pass. I'm not gonna, I'm gonna give you a pretty decent review, and then I guess the procedure is I write it up and I share it with you, and it's largely feedback for, how you've been doing, how you can improve. I don't think there's that much you need to improve on. So I usually put something that helps people along. So be on the lookout for that. And I think there's a deadline on your end, like that you have to fill out a form. Yeah, congrats. So I think everyone's doing okay. So are there any other questions anyone wants to ask before we end for the week?
Yeah, not a question really, but again, I have a suggestion to Ujjwal and Asmit. So I see them working on Kaggle and Keras plus TensorFlow, right? Asmit and Ujjwal.
We are working on deep labs and we are training our models on Kaggle kernels now.
Yeah, are you using Keras and TensorFlow libraries to train the models?
We are using TensorFlow libraries to convert TF records, but we have done it on our own PC.
Okay. The thing I wanted to say is that over the past 3 weeks, I've been extensively working on TensorFlow plus Keras. So I ran into so many issues. Some are silly mistakes or so like that. So I wanted to tell Asmit and Ujjwal that if they happen to come across any error, maybe they can post me. If I've gone through that the same error, I can quickly give them the fix, which will save them time.
Sure, sure. Yeah.
Please feel free to send me any issues that you encounter with training the model.
Yeah, okay, sure. Thank you.
Okay, it sounds good. Anyone else have anything before we leave?
Yeah, nothing from my side.
Okay. Well, thanks for attending.